Hello, Science 10, and welcome to Lesson 3 Energy Conversions. We are going to be discussing energy, and we are also going to be moving into a little bit on Lesson 4 about work. So let's start off by talking about what we're learning today. Today, you are learning the definition of energy, that there are two different types of energy, and within those two different types, there's different forms of those types, as well as we have to talk about how energy is transferred from one form to another. Because we learned back in chemistry that there is a law of thermodynamics that states energy cannot be created nor destroyed, just transferred. So we're going to talk about those types of transfers. So the different types of kinds of energy is essentially understanding that everything has energy in this world. There's many different kinds of energies. But before we can even discuss the types, we need to define what is energy as a whole. So let's talk about energy as a definition. So you have a flow chart to fill out. So just follow along. Energy by definition is defined as the ability to do work. That is essentially what energy means, is it is the ability to do work. Now, when we look at energy, we can break it into two different categories. We can break it into something called potential energy, which is just stored energy due to position or condition. Or we can break it into kinetic energy, which is due to motion. So there's two different types of energies. So please write down both definitions in the correct boxes, and then we're going to go on through potential energies and the types that there are. So again, potential energy is something that is probably new to you, probably something that you've maybe heard once or twice before. So I just want to reiterate, potential energy is stored energy due to position or condition. Now, the position or condition part might seem really weird, but essentially just think of it as stored energy. Essentially, what potential energy means is the potential to do something. So if you look at poor Wile E. Coyote over here, that anvil is falling. But before that anvil fell, it had potential energy. The potential energy that was stored up so that it could fall, the falling part is the kinetic energy. So we convert between potential and kinetic all the time. So potential is the stored amount of energy, kinetic is the movement amount of energy. So in potential energy, there's three types. So let's start with the very first one. The first one is called gravitational energy. Now, gravitational energy is exactly what it sounds like. It's due to the pull of gravity. It's all the energy stored up because of the pull of gravity. Okay, this would be an example such as a rock rolling down the hill. Okay, gravitational energy is the pull of the gravity. Another type of energy that is potential is chemical energy. It's energy stored within chemicals. Now, we know, due to the chemistry unit, that it's actually energy stored within the chemical bonds. And when you break a bond or build a bond, you either store energy or release energy. So chemical energy is within those bonds. It's stored within those bonds. Things like gasoline, food, batteries all have chemical potential chemical energy stored up, being ready to be used. An example would be if you look at this fire, there's wood on the fire. That wood has potential chemical energy to burn to make that fire occur. Another type is nuclear energy. Now, this is energy stored specifically in the atoms. So if we think of uranium is very explosive. It's radioactive. It's bad. It is got a lot of potential energy stored within it so that you can have atomic bombs. All right. So these are the three types of potential energies. Again, potential energy meaning stored energy. So let's go to this idea of kinetic energy. Now, the energy of movement. We're going to start with mechanical, or what we call motion energy. And this is probably the one you're most familiar with if you've heard of kinetic energy before. Essentially, it's just the energy of moving parts, moving things. Okay. An example would be the movement of a wheel on a car. Okay. That would be mechanical energy or motion energy. Another one, which you just learned a couple lessons ago, is something called thermal energy. So thermal energy is the sum of all the energy of the particles that are happening due to random molecular motion. Okay, so if we think of hot steam, the temperature is hot, but the thermal energy could be quite high depending on how many particles there are, because the more particles there are, the bigger the sum of the energy. So there's an example of a burner, okay, that has thermal energy. Electrical energy is something you may be familiar with from Science 9. We talked about electricity a lot in Science 9, and we talked about how it's the movement of electrons. Well, electrical energy is actually a type of kinetic energy. It's the energy that is because of those moving electrons. We refer to it as a kinetic because they're moving. So anything like electrical outlets or static electricity that has electrons moving is also an example of kinetic energy. Light energy, such as the lights in your classroom, in your house, on your phone, on your watch, light energy is what is found in light waves. We call this the electromagnetic radiation or electromagnetic spectrum. Okay, things like the sun and the light bulbs are just simple examples of things that give off light energy, which is another form of kinetic energy. Because remember, light waves move. So if a wave moves, it has kinetic energy because it's the energy of movement. Sound waves or sound energy is energy stored in the sound wave. So again, this idea of waves occurring, waves move, so energy movement means kinetic energy. We can think of things like speakers. Think of how a speaker vibrates, and that's because it's giving off sound waves. It's the movement of kinetic energy. So ladies and gentlemen, we have defined energy. We have talked about potential. We have talked about kinetic. We have defined within potential gravitational, chemical, nuclear, in kinetic, mechanical, thermal, electrical, light, and sound. So now what we need to talk about is lesson 4, which is the very beginning of lesson 4, which is called work. So energy was the ability to do work. So what is work? Well, work is all about energy being converted between these various forms, because as we learned earlier, the thermodynamics says that energy cannot be created nor destroyed, only transferred. So therefore, what it means is that you have to always know where energy is going. Most energy is going to be lost to heat. We know this. We've talked about that lots. But if you think about everything that you use or things around you, they're converting between different forms of energy. Solar panels, for example, take the light energy, those movement waves, so the kinetic energy, and change it into kinetic energy that is electrical energy. And that's why you can run your house if you have solar panels on it. So there's just an example of solar panels. So the transfer of energy from one form to another or one object to another is called work. And we're going to talk about the work formula, which you guys have learned in grade 8, work equals force times distance. And we're going to define work more as we move forward. But for this lesson, you have to be able to identify energy transformations occurring within machines or between machines. So let's talk about some simple examples. A simple example would be a flashlight. It starts with chemical energy, which is potential energy. The batteries inside that flashlight are holding energy, getting ready for it to be used. When you turn on the flashlight, that gets converted into electrical energy. The electrons leave the battery, travel through the flashlight to the light bulb, where it gives you both light and heat, because we know most energy comes off in heat, as its final type of conversion. So this is an example of transformations occurring within a machine. Another example would be something like a battery-powered stereo. We're going to start with the same idea, chemical energy. Inside the battery's potential, what is going to happen? Well, we turn it on, it's got to go to electrical. Electrical energy is just the movement of electrons, which then becomes sound, which is sound waves, which is the movement of sound. So ladies and gentlemen, those are examples. You have one final example in your notes, the energy transformation of a steam engine. That's a tough one. I'm going to give you the first part of it, and I want you to try the last two. It starts with chemical potential energy. So the same idea, chemical. But what does it convert after that? And there's 2 more conversions. I will post the question in our Edpuzzle so that you can answer it and I can see your answers. So again, we've covered types of energies, we've talked about the different forms and how they're now converted. If you have any questions, please let me know.